Hi guys, I'm back with you to solve some problems on modular arithmetic using Fermat's theorem and Euler's theorem. Um, okay, for this session actually I will work with Fermat's theorem, and I'll work with this example. Okay, this is first of all, of course, this is what we have talked about before, Fermat's theorem, and Fermat's theorem states that if you have two integers, a and p is a prime, you can have this relationship here: a to the power of p minus 1 is equal or equivalent or congruent to 1 mod p is a prime, as I said. But the relationship that hold here is that a is not divisible by p. Now for Euler's theorem, it's basically we have also two numbers, but they must be relatively prime, and of course relatively prime means that the GCD, maybe I should add this one actually, the GCD between a and n is equal to 1. So it means that the only number that is the greatest common divisor between the both a and n is 1. All right, so let's take a look at this example here, example 1. And let's say that we are trying to find 7 to the power 100 and simplify this one, or find the congruent to this one using a simple form. And again, this is using module, the modulus 13. So again, we have, so basically the set of integers that we have, it's from 0, 1, 2, all the way to 12. So this is the set of integers. So we have 13 integers, positive integers. This is the modulus. So basically here we want to find 7 to the power 100. Which one of those numbers basically that basically we want to find the congruent, okay, or to simplify this expression to its simple form. Now again, this is 7 to the power 100. Now, by the way guys, this 7 to the power 100 is a very huge number. This one is a very huge number. I'll show you the number exactly. Now it's 7 raised to the power 100. And of course, in cryptography we use large numbers and large prime numbers. Okay, as you can see, this is a huge number. Okay, so it's 3.23 times 10 to the power 84. Well, this is very large number. Okay, now actually if you want to find the mod, this is scientifically, using the calculator, mod 13, so it will give us 9. So now we'll find out how this is going to give us 9. Okay, so actually the answer here is 9, but let's see how we can come up with the 9. Now I want in this example I want to use Fermat's theorem, and I'll use it as follows. Now of course, in order for me to use it, I will definitely take a look at the modulus. Okay, so here the modulus here is, let me change the color. The modulus is 13. Now in order for me to utilize Fermat's theorem, so I need to do the exponentiation. Okay, so I need to put the factorization, the exponentiation, all right, in the form of a to the power p minus 1. Okay, and so in order to break down, okay, that exponent 100, so the way to do it actually is as follows. So I will work with this exponentiation as follows. So I will make it such that I'm gonna be using the p minus 1. So remember, p is 13. So if I use this formula here, if I apply Fermat's theorem based on this modulus, so it is 7 to the power p minus 1, which is 12, is congruent to 1 mod 13. Now remember, 7 and 13 are, okay, first of all, p is a prime, or 13 is a prime, and 7 is not divisible by p. So this is from Fermat theorem. So now I need to construct the exponentiation in this form. I could do it, let me just do it this way. Alright, so basically the 100, we need to have the exponentiation, and so basically it is, I want to make it such that it is 7 to the power 12, okay, times 7 to the power 12 times 7 to the power 12. So remember, this is 12, 12, 12, that's 36, then 7 times 12, then times 7 times 12, 7 times 12. So let's add 1, 2, 3, 4, 5, 6, that's 72, 7 times 12, okay, that's 84, and 7 times 12, 7 to the power, sorry, times 7 to the power 12. So that's, let's count here, 1, 2, 3, 4, 5, 6, 7, 8. So 8 times 12 is 96, and the remaining is 7 to the power 4. So in this case, we are rewriting the power notation into this form, and let's find out what is this equal to. Now keeping in mind that 7 to the power 12 in everything here is module 13, so basically here, let me change the color, and so this is, all these will be 1. Okay, look how we were able to simplify it. So all these are 1, so the only remaining one will be 7 to the power 4 mod 13. Now in this case, we can further break this one down. So again, 7 to the power 4, so it's basically, you can say it's 7 to the power 4 is equivalent to 7 square times 7 square, and this is of course mod 13, and in this case it will be congruent to 49 times 49 mod 13. Now when you do this, so you'll end up, of course, we have here 49, so the 49 mod 13 is 49 divided by 13, which is equal to 3, and the remainder is 10, so this is 10 times 10 mod 13, and then finally we have 100. Now 100, when we divide it by 13, basically, okay, you can find it. So 100 divided by 13, so we want to find out 13 multiplied by, this is 100, this number here is 100, so 13 times 10 is 130, 13 times 9 is still large, 13 times 8, okay, so if we have 13 times 8, that's 2, that's 104, so actually we need to bring it one down, so it's actually 13 times 7, okay, plus the remainder here, so basically this will give us 7 times 13 is equal to 91, and the remainder is 9 mod 13. So obviously this is will go to 0 because 13 is a multiple of 13, which is the modulus, and the answer is 9. As you can see in this example, I was able to demonstrate how we can use the Fermat's theorem, alright, and to simplify exponentiation expressions using this technique. I'll see you guys in the next videos. Thank you.